Hi, my dear class 10th students. We understand that you are under a lot of pressure with heavy syllabus. And we also know that you are getting a lot of confusion where to start, how to prepare, and all those things. Don't worry, relax, as long as Goodbricks is with you. We have a cool and calm solution for you, that is quick revision tour powered by Goodbricks, which boosts up your conceptual understanding and builds strong confidence as well as removes all your worries and stress. Some important instructions before proceeding further. First and foremost thing is refresh your brain by throwing all your worries, doubts and confusions in a dustbin. And when you are watching the video first time, in your first time, watch and listen carefully the video. Carry a notebook and a pen. Pause the video when you are simplifying any problem or question. Comment your answer as quickly as possible in the comment box. Check yourself how far you are doing the answers correctly. When you are watching the video, same video second time, take running notes while watching the video. Evaluate once again your performance and compare your first round performance with the second round performance. These are the important instructions for doing quick revision tour. And there are some important things which you should not do. What are they? Do not play and watch video with high speed. Just watch with normal speed. And one more thing, once again I'm stressing, delete and throw all your worries, confusions, doubts in a dustbin. Then only start your quick revision tour powered by Goodbricks. Let us quickly start our quick revision tour on chapter 1 real numbers. And in this chapter, you have exactly two key concepts. What are they? Fundamental theorem of arithmetic. One thing. One more key concept is theorem 1.2, which says if a prime number p divides a square, then this p also divides a. These are the only two key concepts you have in this chapter. Using these two key concepts, we are going to solve the problems. And in exercise 1.1, using fundamental theorem of arithmetic, we are going to solve problems like express a composite number as a product of its prime numbers or prime factors. Second thing is find LCM and HCF. Third, check whether 4 to the power of n can end with 0 or not. Check whether 6 to the power of n can end with 0 or not. So this kind of problems which we are going to solve in exercise 1.1 using fundamental theorem of arithmetic. Similarly, in exercise 1.2, using theorem 1.2, we are going to prove the numbers such as root 2, 2 root 3, 2 plus root 3, this kind of numbers we are going to prove as irrational numbers. Now, whatever it may be, the problems which are there in this chapter, all these problems we are going to solve the basic knowledge or previous class knowledge. What is that? Prime and composite numbers. So we have to recall the knowledge related to prime and composite numbers. Then you can easily solve the problems which are there in this chapter. So in this video, we are going to discuss all these topics. Along with that, we are going to solve some problems. Let us quickly recall your previous classes knowledge. What is that? Prime and composite numbers. And see here on the screen, we have provided three different numbers. What are they? 7, 13, 23. And if you observe their prime factors, 7 has 1 and 7, 13 has 1 and 13, 23 has 1 and 23. It means these three numbers, 7, 13, 23, these three numbers are having 1 and itself, 1 and itself, 1 and itself. So the numbers which are having exactly two factors. And what are they? 1 and itself. This kind of numbers are called prime numbers. And here we have provided some list of prime numbers from 1 to 50. And let us now look at composite numbers 9 and one more number 10, and then we have one more number 18. And if you are observing their factors 9, 10, 18, these three numbers are having more than two factors. In addition to 1 and itself, they are having extra factors. So this kind of numbers are called composite numbers. Next, let us discuss about theorem 1.1, and it says that every composite number can be expressed as a product of its prime factors in a unique way, and this is also called as fundamental theorem of arithmetic. And based on this, we have problems in exercise 1.1. What are they? These are the problems. Instead of wasting time on this, let us quickly jump into the problems. So see here, the first problem, express 24 as the product of its prime factors. So let us take 24 and factorize as the product of its prime factors. So 2 is the prime number which can divide to this 24. So we can write 2 into 12. Then again 12. Let us do prime factorization. Then again 6. Finally, we have all these prime numbers. So we can express this 24 as the product of all these prime numbers. What are they? 2 into 2 into 2 into 3 is nothing but 2 cube into 3. So we have expressed the given number as the product of its prime factors using fundamental theorem of arithmetic. Let us now express one more number as the product of its prime numbers. So let us take 50 and express it as product of its prime numbers. You can write 50 is equals to 2 into 25. Then 25 can be written as 5 into 5. We have done the prime factorization. So we can now express 50 is equal to 2 into 5 into 5 is nothing but 2 into 5 square. So this is how we can express the given numbers as a product of their prime numbers. Let us now solve one more problem. What is that? We have to find LCM and HCF of 24 and 50. Whatever it may be, first of all we have to write their prime factors and we need to express them as the product of their prime factors. Now you have clue here on the screen. To find LCM, what you have to do? We have to select highest power of each prime factor. So to find LCM of 24 and 50, first of all we have to select the prime factors which are there in these two numbers. So what are they? 2, 3, 5. These are the prime factors. Second, we have to select their highest powers. So what are they? 2 cube means 3. 3 to the power of 1 is nothing but 1 and 5 square is nothing but 2. So after selection of prime factors and their highest powers, we have to multiply and finally we will get 600 as the LCM of these two numbers. Next, let us find HCF of 24 and 50, and you have clue here on the screen. What is that? Select lowest power of only common prime factors. Only common prime factors, not all prime factors. So to find HCF of 24 and 50, we have to write only common prime factors. So what is that? 2 is the only common prime factor. First thing. Second thing, we have to select lowest power. So here 2 cube is there, here 2 to the power of 1 is there. So we will select 2 to the power of 1 because it is the lowest power. Finally, HCF of these two numbers is 2 only. Let us look at one more problem, and in this problem also we have to find LCM and HCF of two numbers. What are they? 24 and 90, and here we have expressed them as the product of their prime numbers. And I am giving few seconds of time. Please enter your answer in the comment box. LCM of 24 and 90, please enter in the comment box. Hope you have entered. Now see here on the screen. To find LCM, what we have to do? We have to select highest power of each prime factor. So first of all, let us see 24 and 90. In these two numbers, 2, 3, 5, these are the prime factors which we have. Second thing, we have to select their highest power. So 2 cube, 3 square and 5. So finally, after selection of prime numbers and their highest powers, we can write as shown here, and after multiplication and simplification we will get 360 as the LCM of 24 and 90. Now again I am giving few seconds of time to calculate HCF of 24 and 90. Hope you have already entered, and now you please pay attention. See here we have the clue. To find HCF, what we have to do? We have to select the lowest power of only common prime factors. Only common prime factors, not all prime factors. So 2 is the common prime factor, 3 is the common prime factor. First we have selected common prime factors. Second we have to select lowest power. So 2 to the power of 1 is here and 3 to the power of 1 is here, is the lowest power. So finally, to calculate HCF of these two numbers, we have selected only common prime factors and their lowest power. Finally, after multiplication, we will get 6 as the HCF of these two numbers. Now again you have two more numbers to calculate LCM and HCF, and we have provided their prime factorization, and I am giving few seconds of time to tell your answer. Hope you are trying and entering your answer in the comment box, and now pay attention on the screen to calculate LCM. Here is the clue on the screen. What is that? Select highest power of each prime factor. So 2, 7, 13. These are the prime factors which are there in these two numbers. Second, we have to select their highest power. In each case we have only 1, 1, 1 as the highest power. So we will be writing as 2 into 7 into 13, and after multiplication we will get 182 as the LCM of these two numbers. Hope you got correct answer. Now I am giving again time to calculate HCF of these two numbers. Hope you entered the correct answer, and see here, to calculate HCF, what we have to do? We have to select lowest power of only common prime factors. And if you look here, 13 is the only common prime factor and its lowest power is 1. So 13 to the power of 1 is nothing but 13 is the HCF of these two numbers. Hope you entered both the answers correctly. Now let us solve another problem related to exercise 1.1. And in this problem they have given HCF of two numbers and they are asking us to calculate LCM of these two numbers. And we know the relationship between LCM into HCF is equals to product of two numbers. And they have given HCF 9. So in place of HCF we are going to write 9. Product of two numbers is nothing but 306 into 657. That is what we are going to write. Now, since we want to calculate LCM, let us take this 9 towards right side. So it will divide to this, whatever is there towards right side, it will divide. So finally LCM is equals to this by 9, and after simplification we will get 22,338. What is this? This is the LCM of these two given numbers. Let us now check whether 6 to the power of n can end with 0 or not for any natural number n. For that purpose, let us observe some numbers which are ending with 0. So here you can see 10, 20, 40, 100. All these numbers are ending with 0 and all of them are having 2 and 5 as their prime factors. From this what we can understand is the numbers which are ending with 0 should have 2 and 5 as their prime factors. Now if you take the given number 6 to the power of n, here 6 is having only two factors. What are they? 2 and 3, but not 2 and 5. Since 6 is not having 2 and 5 as its prime factors, we can say this 6 to the power of n cannot end with 0 for any natural number n. Let us look at one more problem. In this problem, they said that this is a composite number. Now we need to give reason why is it a composite number. For that, first of all, let us take the given number, and from that, if you take 13 common, you can write 13 into 7 into 11 plus 13 into 1. So here when you multiply 7 into 1, 77 you will get. After that, when you add, you will get 78. Now this 78 can be written as the product of its prime factors. And when you multiply all these things, you will get 1014. It means the given number is a 1014, and this 1014 is having more than two factors. What are they? 1 and itself, and other than that, extra 3 factors are there. In the beginning only we discussed what is composite number. Composite number is nothing but the numbers which are having more than two factors. So you can see this given number means 1014 is having more than two factors. So that is why we can say this given number is a composite number. Let us solve this word problem in this chapter. In this problem or question, they said that Sonia and Ravi are driving around a circular path, and Sonia takes 18 minutes to complete one round around this path, whereas Ravi takes 12 minutes to complete one round around this circular path. Now the question is, after how many minutes both Ravi and Sonia are going to meet at this starting point? This is what the question. See, now they are going to meet at this starting point. So to answer this question, we have to calculate LCM of this 18 and 12. For that, first we have to express 12 and 18 as the product of their prime factors. And to calculate LCM of these two numbers, we have to select all the prime factors and their highest powers. So 2 square and 3 square we are going to select, and after multiplication you will get 36. Therefore, after 36 minutes, both Ravi and Sonia are going to meet at the starting point. Now we reach to last point of this quick revision tour of this first chapter, and theorem 1.2 says that if a prime number p divides a square, then p also divides a. Using this theorem and using contradiction method, you are going to prove the given numbers as irrational numbers. For quick solutions, please visit our website goodbricks.in. Before proceeding further, please find the link in the description related to worksheet on this chapter. Let us do quick summary on what are all the things which we have discussed in this video. In this video, we discussed about prime and composite numbers. Using theorem 1.1, we have solved problems like expressing the given numbers as the product of their prime factors. We calculated LCM and HCF of the given two numbers. When they have given HCF of two numbers, we calculated LCM, and we also checked whether 6 to the power of n can end with 0 or not. We also discussed the reason behind why this given number is a composite number, and we discussed one word problem based on LCM. In addition to all these things, we also discussed how to prove the given numbers as irrational numbers. If you think our quick revision tool is really helping you to save your health, energy and time, and of course our quick revision tool is also helping you to remove all your worries and stress. If yes, quickly share with as many friends as possible. Thank you for watching and learning. Have a nice day.